Okay, our group meeting for lesson 24. Got Brianna, myself. Don't believe Mariella is going to make it today. And we'll go ahead and get started with the quiz. Just like biting my tongue here. Let's see here.
All right, number 2.
Sorry, I'm still pulling it up. Sorry.
Oh, okay.
Should have had it pulled up earlier, but. Okay, hopefully we can get through this. Okay, number 2, sorry.
Quantitative, so numbers, so the first and third one?
I don't see. I thought it might have been the first one, but I don't think it is because the telephone number isn't mathematically correct, right?
I guess so.
Sorry, that was
Oh,
the
you're
only one.
fine.
Okay, number 3. Sorry, I'm trying to pull up the.
So it's just the number of people randomly selected in the classroom?
Okay. Okay, sorry, I was trying to pull up the other stuff too. Okay. Uh, Students have no control. Students this is the experimental one because students have control over the sampling method, right? That
I
they
thought it
use.
was an observational study
Observational study.
because the students had no control over the price of the individual cereals.
Oh my gosh. See, that's where I'm like, oh, that I thought it was experimental because they were studying the prices of cold cereal at a grocery store. So they went to get the samples of the cold cereals.
An observational study.
And they actually controlled how they were going to get those prices, the sampling. That's
I feel like we've had this one before. I don't know where to find it again, but
yeah. So it was in lesson 2. So observationals can't control the method of measurement. Experimental is where you can control how you collect the data, basically. And so I always thought an observational study was like if they just went into a room and grabbed all the data sets that are already there, and then they put them out. Where experimental is where you're actually going out to get the data and doing it. Um, well, how many times do we have to do this quiz? 2?
2 each, yeah.
Okay. Well, let's just do 1 and 1. It won't hurt, right?
Okay.
For Math 2 tuning project for student. Collected data. So this one, see, this is where I started to like really doubt myself. So we did have this before. They saw that the data was wrong. He's actually 21, not 12. So I put the median will increase. Is that what you have?
Well, the median is the middle number, so it wouldn't really matter, right?
Or it's not possible to determine out the full data set? I mean, you don't
Well,
really.
with the full data set, you would have all your numbers. So
Mhm.
21, 18, 21.
Okay, so the median will stay the
Okay, it
same.
would change. It would increase because then your numbers would be in order 18, 20, 21, 21, 25.
Hmm.
So it would increase.
The decrease. Okay, that's what I was thinking. Okay, okay. So this is where what I started to go downhill on the 65, 68, 95, and 99.7 rule. So this one, the time complete the standardized exam, BYU testing center is 70 minutes and standard deviation 10 minutes. So on this one, um,
It'd be standard deviations away from the mean, so it'd be 68, right?
but isn't the mean at 68 or is that the median? Well, the mean and the median would be the same at this part, right? Because this is what I was looking at.
I don't think that matters. Just what percentage is under 50%. And that 68, 95, 97, 99 rule
Mhm.
follows the different deviations. So if you see that 50 is two standard deviations and it's 68. I don't know if
It's
that makes
68. It
sense.
stays within the 68 then. Because I started to look at it. You remember how you drew it out the last time
Yeah.
and stuff? So I think you're the expert on this one right here.
I wouldn't put me that far, but
No, because you had done it before. Could you see what I wrote on there? And I was trying to figure it out from there. So I
yeah.
wasn't really sure, but we can definitely do the 60. 'Cause see, the standard deviations are the 70 in the middle, and then the standard deviations 50 and 60. So I just kind of thought, is that what it looks like? But then how do you count for the rest of it, right? Because it's
Yeah.
yeah. So I'm confused as to where the 95 comes into place because the 68 we know was in there, but I think you're right. I think it's 68%. So we just put 68 in there, huh?
I think so.
Let me see what I got on my answer when I did this. Hold on. And by all, I mean totally confused again. Then I have a hard time with this one. Um, yeah, I wouldn't put 95, but we'll stick with 68 on this because I don't understand the give your answer accurate to one decimal place either.
Yeah, I don't know. Why is this so hard?
That's what I'm saying. Why is it so? Why can't I? I mean, we did well, but I think I just have to dig back more in our quizzes and our exams from before because I did say to pull up the exams from before.
I feel like I did
It
all these
just
questions though, but I don't know where to freaking find them to go over them again.
and my whole thing was I figured that I should know the methods now and I shouldn't have to look back. It should be pretty, or at least identify which formulas to use. But I'm having a hard time. That's why I didn't go back to the other exams. I wanted to just see if I could figure it out,
I
off of
haven't
what we already
prepared
did.
enough yet for this exam.
Yeah, I gotta go back and look. Me neither, because apparently it's not working. I didn't know enough. Okay. So this is another one. So the LSAT scores are approximately normal. And when I looked at this, because it said find the 35th percentile of the LSAT scores, um, and to use the applet, I thought that when they said to use the applet, I put in 35% in the applet to get um to get the where is it? To get the Z score, and then I use the Z score in the calculation. I don't know if that's the right way to do it, but I had an old calculation in here, and so I didn't even use. So the calculation was taking the Z score and multiplying it by the mu plus the standard deviation. These are just
Yeah.
old that I had before.
I did not go over the review as much as I should have.
No, I didn't. Yeah, no, I didn't go through over the review. I was just trying to. I was thinking that okay, I should know this, right? And
Yeah.
now I'm like totally confused because I don't know this as well. But we're gonna just go through the quiz and then I'm gonna go back and look through the review.
Yeah, I'm
See what
trying
we
to.
do.
Well, the
So for
review is the same as the question, so like we're doing the review now. Like, oof,
right, right.
I'm trying
Um,
to know. Maybe.
but without my notebook, I can't see like the formulas that we were supposed to use.
um,
Um, and I'm just going back through all the chapters, but I'm only review. I didn't go through this review as much because I've been trying to go through all the chapters again to
Yeah.
kind of do, and I'm not even close to getting to where I need to be. So for this one, my answer was um, 155.3.
150.
5.3.
155.3.
But again, I don't know if that's going to be accurate. That's just what I kind of thought because I didn't even put in the sample of 157. It just stayed with the view and the standard deviation and the z score at 35 percentile.
Yeah. Hmm. Let's see. Let's see. I'm going all the way to the bottom, and maybe we could start away from the bottom up since it's the most, or is it in order of what we know?
Oh, I don't know.
Not really.
Yeah.
It would make me feel better if we actually knew some stuff first.
All right, I'll go to the bottom with you. Which one you just want to start with the last one?
Sure.
47. Okay.
A business marketing may help.
Mhm.
Which procedure? I hate these questions. Oh my
But this is
god.
a linear relationship, right? So we know that the linear relationships are the bivariate, what we just learned. Um, so it's gonna have to be the linear regression then, right? That
Yeah,
should
you're
be.
right. You thought that through a lot better than I did. I kind of shut down.
No, yeah, I just looked at the words.
I just thought it was a word problem and I shut down. Um,
Okay,
American
46.
counselor conducted a study of couples categorizing each of the couples as see the percentage. Um, oh, so it uses couples. So mm,
So these are independent studies, right? Because you've got the um, the communicative couples who ended in divorce, so versus the non-communicated couples who
yeah,
and
but they're paired because you have to have one to have the other.
they
Oh,
they have to have one. Do they affect each other? Do each of their groups affect the data in the other groups?
I don't know.
Because if you study the communicative um, couple, does that affect the the groups that are non-communicative?
Guess not.
Probably not, right? Because so you can get those samples and they don't affect each other. So they are they are two, but they're independent sample t-tests.
Independent sample t-test.
Oh wait, what's a chi-square test of independence? Nah, I don't know. I think it's independent only because they don't the data doesn't come from each other. If we
Mm,
get that wrong, I'll be really surprised. But you know what? I got a lot of things wrong that I was surprised about. So I'm sorry if I'm leading you down the wrong path.
okay. All
Um,
right, 45. An attorney wants to know over 45. Would that be a test of one proportion?
yes. For the percentage of homophilies in Nevada.
I don't.
So it's either going to be one sample Z test or one sample T test, right? So a Z test is off of population, a sample of a population, right? What's the difference between a T and a Z again? Hold on. See, my
Um,
notes would have been really good right now.
test.
Let me just look quickly.
Well, Google says that Z tests are when we have a larger sample than T tests, but I don't think that's.
Oh,
A t-test is used for testing the mean of one population against a standard or comparing the means of two populations if you do not know the population standard deviation.
so
Oh, so if you don't know the standard deviation, you should use a
that's right.
t-test. And if you do know it, it's a z-test.
That's right. That's right. Okay, where did my quiz go? Shucks. Okay, so we don't know the standard deviation on this, so so this is going to be a t-test then, right? Wait, hold on. Nevada, who are over so it's either going to be that or test of one proportion, but the one proportion, gosh, no. Let me see something. Okay, so I believe it's the t-test because we don't know the one sample t-test. We don't know the standard deviation, and we're really not studying proportions at that point. Yeah. You ready to take the leap with me?
Sure.
Okay, 44. Engineers at oil refinery find out how easily gasoline evaporates by measuring its vapor pressure. They make gasoline. They need to determine whether its vapor pressure is high enough. Standard deviation of vapor pressure of the gasoline made refinery is going to have 3 pounds. Which hypothesis test will be most appropriate for this task? Well, it looks like determine whether its vapor pressure is high enough. It looks like it's going to be a one sample Z test with
Because
the
we know the standard deviation.
yeah.
Okay.
Okay, 43.
Mm.
So it doesn't say they carry out a study to test the effectiveness of a new prenatal care program. So they take 30 mothers and they participate in the program. Okay, so they're taking a sample out of the population, right?
One
Of
sample t-test. I don't know.
taking a sample, but they're going to compare it though to what the U.S. standard is. So they have the U.S. standard, and they're taking these 30 mothers out. Um, which hypothesis test? So it's recorded. This is definitely. Let me see. Um, so what are your thoughts?
Oh my gosh.
Because I think that there is some type of dependency on it, right? Well, is there? Is it an independent sample test or a paired sample test? I think it's one of those two. Sample t-test, but it's either independent or it's paired.
That's what I first thought about is t-test,
Yeah.
but I don't
Um,
know which one.
because they're going to compare it to the studies in the US. So I guess the question is the 30 mothers who are taking and they go to the program and the baby, or wait, part of me wants to say that it's independent, but I'm not really sure. Well, I guess we can just make a decision and then come back to that later. But they're paired samples. So, you know what? It it is going to be a paired sample t-test. So maybe we would just do that one.
But on paired sample, don't you subtract or the difference? The difference comes in play. Do we need the difference for that?
So the CDC carries a study to test effectiveness. So if they're going to conduct the study to see if the prenatal care program is going to reduce the number of low birth rates born, wouldn't they have to? Yeah, I mean, they don't have the two samples. I see what you're saying. So the hypothesis is either going to be equal.
Less. It's
Yeah, it's going to be
your
less
null.
than the
You
less
have an
than
alternative of less than 2,800 or something.
or whatever the yeah
Yeah.
yeah. Yeah.
So would it
So
just be a one sample?
you're right. It's going to be a one sample test. Okay.
What decision?
Okay. What decision you make based on
Oh, this is a whole group one that we should.
which one? Number 42? Is that the one we're on next?
Yeah, but it's part of a whole like set of questions.
Oh, okay. We got to go up then.
Yeah. I don't know where it is. There's like for the next 3 questions. The next 4 questions, conduct a hypothesis test. So you have to use another set of data to conduct the hypothesis test. Okay, I'm guessing 31 is where it started.
Yeah. Okay. Pressures of supply and demand.
We did this one.
Mhm.
I wish I could remember when I downloaded this stuff so I could go back
Mhm. I
and
know. You
save
know
my stuff well.
how they should have like saved all of the worksheets that we had in the under the names of the
Yeah,
that would make, in fact, I'm probably going to do that now. Save as direct flight costs. You know what I mean? So the
yeah.
data's already in there.
I know we did this one, but I don't know where we did it and what we use. And I don't
Yeah.
know.
So she did N90 equals 90, right? Non-stop dynamic flights, 90 days in advance, and then found the lowest published 14 days in advance. The sample correlation coefficients. So check. So sample correlation coefficient is going to be inference, right?
Yeah.
Explanatory and response variables. But in this case, your explanatory would be 90 days and your response would be 14.
What chapter did we do this?
The coefficients, we just did them. Let's see here. No, that's a linear route. Well, let me see. Um, so yeah, the coefficients we had just did in the chapter 23. Computed sample correlation. So, um,
We're struggling hard.
yeah, I knew this is gonna happen. With the so we have to determine which one is our slope, right? And which is one is our y-intercept. I believe that the y-intercept would be the 14 days. That's what I'm thinking. And then the slope would be the wait, I'm sorry, the explanatory, the variable x would be the 90 and the variable will be the y. And so we usually do it to the slope, right? Which is our coefficient. So that would be b 0.627. Let me share my screen and see if it makes sense, okay?
Okay.
Okay, here we go. So I put in the 90 days here, 14 days here, and 0.627. Is that correct for the sample coefficients? This is under standardized.
So, yeah.
0.627.
Oh, gosh.
Here we go. And the scatter plot using these two variables. Scatter plot for referring correlation answers the question side of the data. So the scatter plots, you know what's interesting in this, and this is where I get a little confused. So I can create the scatter plots, but it always looks different from this. And what is this? Do you know what this is? Because this is a scatter plot too.
Yeah, but I don't think the data.
It's not based on linear, right? I
Yeah.
mean the residuals. So we take these and then we insert scatter plots. Oh, what the heck is that?
You use the first column as like a label, I think.
Oh, did I?
Because you
No.
only need the residuals.
Oh, I thought we did both of them. A, B. Okay. See, and this is the part that I'm still not super confident on either. Okay, so there's our scatter plot right there. So what does it say about it? The question is we have to explain, right? Linear with fairly strong negative association, positive, strong negative. And then if we go back to lesson, oh, sorry, 3, it explains this scatter plots. Oh, I think it was lesson 22 that did it. Hmm. What was the one that did explain the different scatter plots of megaphone? There we go. The graph. So this one doesn't look like it's negative. I mean, what do you think it is linear. It's kind of a linear pattern, but it's not really skewing. It's like straight across.
For my data, I got 0.972.
Can I see your screen?
Hmm. So I entered it all in this, and then what's that?
So yours
Would
is,
this be the correlation coefficient?
oh yeah, you're right.
Because the next couple questions ask for these.
Okay, you're right. So let me see if mine's different from, no, mine's the same. So it is 0.780, right?
Yeah.
And so what did my test go?
And then we, I think fairly strong positive because it's close to 1. And it looks
Okay.
kind of linear. I don't know.
No, that's what I was thinking.
And then the
The
Y
only thing is you have that outlier, right, that takes you down to the
distribution.
bottom. That's where is it? This little baby here. And I think that's what makes it look like it's more negative, but most of it is up above. So I would agree fairly strong positive.
Looks different. Oh, that's not it.
Does yours look different? Let me see yours. Oops. Sorry, Fran. So yeah, that's what I had off of the oh, okay. You're right. That's the one we should be looking at. So it is fairly strong positive because it's going upwards. It's going to the right here. The graph is going up. Okay. So
The Y intercept.
so that's gonna be the second one, right?
The Y intercept's the first one. So negative. But I think our numbers are different and I don't know why.
Well, the first one you have is which one?
Y intercept negative 17.087.
Yeah, our numbers are different. Oh, you know why? Did I put, because I put the 14 days as the explanatory or the response variable.
See, this makes me scared because last time we did this data set, we used a different test.
Yeah,
And that's why I'm getting so like.
so it could be another
Because on
test.
the other test, we wouldn't get those answers though. We wouldn't get the correlation and we wouldn't get.
Right.
So that's why I think we're doing the right test, but it's like, it's messing with me. I don't know.
Yeah, the only thing that's driving me to that test is of the because of the wording in the quiz,
Yeah.
um, the y-intercept and so forth. But we just have to because we can get the same answers if we decide which one is our response and which one is our explanatory. So you and I have different numbers because we put them differently in there, and so is is the which one is based off of the other, right?
Well, they're not really based on like neither one are based on
They're
like
not. They're not. So that's where it gets kind of skewy.
I just copied and pasted it how it was in the data set.
The reason why I put 90-day as the explanatory is because it was first, and then the 14-day was sort of the based off of that 90-day. I mean, or it comes, I don't know, sort of later. That's why I put it as the
Well,
second.
the 14 days in advance, you put that one first.
I put the 90 days here as explanatory, and then the 14 days there's the response because that's what you get afterwards.
Yeah, but technically you did the 14 days in advance first,
I did
right?
14 days.
Because those flights are earlier.
Well, you have to do 90 days, right? So so when she studied it, she pulled up the 90 days for the same flight, and then for this same flight, 14 days late, 14 days in advance, then she went to, and then she got the second set of costs. So 90 days would be first in the data set, even though it doesn't show up here. The data represents lowest published fares for one way. Um, book 14 days in advance or 90 days in advance.
So 115.640. as your y inner slope.
Yeah, that's what I got.
And then the slope is 0.627. Prediction for how many days in advance?
14 days.
So you put that as x. And you predicted is 124.414.
Which one? You
You
put
put,
that as X
yeah.
200, right? $200.
Oh, you put it as $200?
The question, because I saw a comment in there. So it says
Oh.
200, comma, 90 days before flight.
Well, I think that answers our other question listed. 14 days would be X. Is that what we put?
14 days is, so you know what, you're right, because they're doing it the other way.
They're doing it 14 as
That's
X.
confusing that they explained it. Yeah, because on this question it says 14 days.
And you would
Wait,
put
wait,
that
wait.
in as
Predict
X
the
because
price
that's what we
of
know.
this is 14 days. Wait, wait. Okay. Predict price of tickets listed 14 days before flight based on the same flight costing $200. 90 days before a flight. But
Because then you, because that's X. So you know X would be 200. So then you're trying to find response would be 90. You get it?
wait, predict the price of tickets listed 14 days before a flight based on the same flight costing 200 days. 90 days before a flight. So they want you to predict the same flight that you got 90 days before a flight at $200, costing $200, 14 days for a flight. So your 14 days is still dependent on your 90 days.
But you know your 14 days. And that's X. Like that's what you enter as X. So you need to have that as your X variable.
You know your 14 days. Yeah, right here. So we're saying that your 90 days, so it's really saying $200 is based off of your 90 out of the 90 days. Which flight of
But
these,
you want it as the 14 days.
so which one of these 90 days, which is how much out of the 90 days is going to be about 200 at 14 days, right? I'm confused. And so, well, let's look
No,
at,
you're
let's,
right,
let's
right.
undo this. I'm
I was
gonna,
reading the question all backwards.
yeah, that's what makes it confusing. Let me just do this. Let's do,
So 115.640.627 and then 240.979.
240.979, right? So, try not to confuse myself here, but okay, so so 240.979 is the
But you have to round up.
going to be 241 then, huh?
Yeah.
And 0 to that, just to make it look like a 1 decimal. But now we switch it. So for the next question, oh, no, 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 now it says the same. Used to be 14 days or so, 95%. So we just have to make sure we have 95 in here, which we do.
For the slope of the regression line. So 0.518 would be the lower bound. Oops. And the upper bound would be 0.735. And the margin of error would be 0.108.
Did you calculate that by subtracting and then dividing by 2?
Yeah.
Okay.
I already have it pulled up in this document. I get, like the.
So good. um, so I want to copy and paste it. Right. Okay. For a question, can type the hypothesis determine the slope between is not equal to 0.
B equals 0, B1 equals not equal to 0.
B.
So the third one.
Yeah. Oh, is that the slope? B1. I think B1 is the slope, right? If the slope of the true linear regression is not equal to 0.
Oh yeah, so it's the last one.
Yeah, but I don't, wait. Tell me again what the difference is between the little b and the one and the big B.
That's just how I learned it.
Yeah, because I have
Big B stands for slope.
it's the beta, right? Big B, little b. Go all the way down. Okay, B1 is slope of the line, and then big B is the true slope of the line. Okay, so we have that's the difference.
So we want it as the big B.
B1 is the slope of the line. Was the value of the test statistic, and that one is that one is this one, right? For the slope, 11.510. Is that correct?
Oh. Yeah, but then the p-value, we've never had one that has the like time,
P-value is going to be 0.00 because this is minus 19. So it'll go back 19. This one will go back 19 spaces. And same with the other one and go back 9 spaces. So then that makes our p-value 0.123. We're going to reject the no sufficient evidence. So it's going to be third. Reject the null. There's sufficient evidence to suggest that the slope of the true linear regression does not equal to zero. Oh, we did that one, that whole set.
But we're not even halfway through the quiz, and I have to leave in a couple minutes.
Oh, shucks.
I know.
Yeah. Okay, when creating a scatter plot residual plot QQ plot, which of the 5 assumptions about linear regression are being checked? You really missed my notebook. Okay.
For number 7, that's a weird question.
Oh, we're going back up to 7.
I'm sorry, I'm all over the place. I'm just.
Okay. Yeah, I tried looking at that one, and this one I couldn't figure out because
That's why I went back and read it. Like, it says that it's right skewed, so I would assume it is, but it's only 2 people, so.
I just gonna put we cannot be sure until we examine the data set, but because it's not gonna be normal. Well, hey, hold on. It's just right skewed. Oh, okay, because it says it's right skewed inside the
But I guess it would be right skewed even though there's 2 people. I just.
Yeah, because it says it's right skewed. We'll just put it in there. Following information, next 2 questions.
Oh my gosh.
So when I did this one, let's see here. I got 2.683 when I did the calculations, and I don't I mean, I can go back and do it again, but that's the z-score I came up with.
Okay, I'll have to do that. I haven't yet.
Yeah, so I just took the, do I still have it open? No, I closed it. So I'm having problems with that spread, that worksheet. I can pull it up again. But I had a formula for before, and I just plugged everything in there. So, right here.
Okay.
So if you do that, let me see. This.
That's a nice little thing you made there.
Yeah, it helps me kind of
Wow,
see.
that's really nice.
Yeah, because then I can, but I kind of do it 2 different ways. I started doing it this way, example, the mu standard deviation n, and then it would give me the standard deviation or the z-scores here.
Yeah.
So if I plugged it in, and all it really is the same calculations that we used before. But I think I also plugged it in, so I wanted to see, so in here we said that the mu was 8.4, deviation was 12. And then our sample is 20. And the mean capacity is 8550. So then the oh, now it's giving me a different standard deviation. Oh no, z-score. Okay, so this is what I got here, which was our standard deviation
So the
divided by the square root of the sample mean. But now that I'm looking at it, the z-score is the x minus mu divided by z-score 7. Okay, so it should be 2.236. This should be the answer. Is our z-score of the sample, which is that formula there. So
okay.
that's the wrong one. Let me put it.
Number 10 is the last one, I think. I'm just going through things that I knew real fast, but they're not that easy.
So what's the probability of the sample mean capacity of 50 randomly selected that may be greater than? Because you got to leave right now, huh?
Yeah. But number 10's D.
D.
Yes. Or no, it's the the probability of rejecting whether it's true or not. I think that's what we've done in the past.
Which one is
Or
this
wait, what's the question ask?
significance? The significance of a hypothesis
Oh,
test.
never mind. I think it's a
Oh,
probability of a type 1 error.
the
We've had that on past tests.
no, I think you were right the first choice. I think it
Well, no, I
is
think that
the last one. Is which of the following best describes the notion of the
that's the
significance of a
p-value of a hypothesis test, but the significance level.
the p-value is the first one. The probability of taking a statistically extreme is when you calculate assuming no hypothesis is true. That's
Significance
a
level
p-value.
p
This
type 1 error.
type 1 error is if you said it was false, but when actually the p-value was true. I mean the not p-value, but the you rejected when you shouldn't have rejected. In type 2 errors, you didn't reject when you should have rejected, and then the probability of rejecting HO if it's true or not.
Well, here, my on the lesson 9 homework quiz.
Hmm.
Where is it? Did I just close it? Oh no, right here. This one type the significance level of hypothesis test.
Where are you? Significance of the probability of a type was it? Oh, okay. Wow, you're good. So type 1 error then. Okay.
Well, I'm sorry I haven't been that much of a help today.
No, no, that was we'll we'll get through this and I'll figure it out. I'm just gonna take some more time. But we have only 2 hours to do this, right?
Oh, what? No, I think this one's unlimited. It just says the estimated length is 2 hours,
Oh, sorry. Okay,
but it's
good.
open, it can be open all day. So I don't know what your schedule looks like for the rest of the day, but I get off work in 6 or 7 hours, so I can come home and do it again.
Okay. Yeah, I have to finish it now because when I get to
Okay,
work, I'll miss the window because it
gotcha.
closes. By the time I get home, I'll only have half an hour to finish it. So,
Got it. Makes sense. Well, good
yeah.
luck. I wish
Thank
I could be
you.
more of a help.
No problem, but thanks. We'll talk to you. Well, good luck in the final too. We gotta take that
Well,
this week.
yeah, you too.
Okay. What
All right,
when do
bye.
bye
What?
bye. No, I was like thinking when do we um take our final by?
I'm not sure, but the PowerPoint is due on Saturday, I think, right?
Yeah.
We need to work on that too.
Okay. That sounds good. Let's concentrate on our final and then I'll put some more information in there.
Sweet.
Okay, thanks. Have a good one. Okay, bye.